The half-angle identities are going to serve as useful tools in helping us to further evaluate trig expressions. And the half-angles just involve trig expressions with half of an angle. As you can see, sine theta over 2, that's half of an angle. Tangent theta over 2, that's half of the angle. Now, sine and cosine, you've just got your half-angle identities right there. Tangent, you've got 3 different options you could choose from. Either of these are going to give you the same exact answer. The first thing you want to do to be able to use these is rewrite angles as a half angle. Let's say we had 3 here. We could write 3 as 6 over 2, right? 6 over 2 is equal to 3, and it's half of an angle. If we had 80, we could rewrite this as double 80. That would be 160 over 2. This would be half of an angle. Let's start by taking a look at this tangent 105. Now if I drew 105 degrees on our coordinate plane, we'd get a reference angle of 75. That's not a special angle. That's not going to be something that we could find the exact value of. So let's try to apply our half angle by doubling this 105 and rewriting it. Doing that, we'll get tangent 105 doubled is tangent 210 over 2. Now 210 is a special angle. If I rewrote 210 on my coordinate plane, I'm going to get a 30-degree reference angle in quadrant 3, and that is a special angle, so perfect. Now that we've rewritten as a half angle, let's choose which of our identities we want to use. Well, we have tangent, so we've got 3 different options. I'm going to pick this option in the middle, 1 minus cosine theta over sine theta. Doing that, we'll get 1 minus cosine 210 over sine 210. Here we've got our triangle drawn on our coordinate plane. Perfect. Let's go ahead and see if we can substitute some of these values in. So that'll give us 1 minus cosine 210. This is the cosine of this angle here. That would be negative root 3 over 2. Let's replace that. Negative root 3 over 2. And that's replacing the cosine 210. All over sine 210, sine of this reference angle here would be negative 1/2, so that's going to be all over negative 1/2. Now to simplify this out, we're going to have to clear our complex fractions here. I see I could do that by multiplying the top and bottom by a 2. So I'm going to do that, top by 2, bottom by 2. The 2 is going to distribute, giving me 2 minus, these 2's will cancel out, negative square root of 3, which is just going to turn into a plus, all over negative 1/2 times 2. That's just going to be negative 1. And finally, we can move that negative 1 up to the top. We don't need to keep a negative 1 in the denominator. That'll give us negative 2 minus the square root of 3 as our answer. Let's go ahead and do a quick example involving radians. Here we have sine pi over 12. If we want to rewrite this as a half angle, it's the same thing even though it's radians. So we want to double this. That's going to be equal to sine 2 pi over 12 because we doubled this pi over 12, and then that's going to be all divided by 2. Now look what's going to happen to this 2 pi over 12. That's going to simplify to pi over 6. So that would be sine pi over 6 all over 2. And this pi over 6 is what we'll be plugging in, which is a special angle, so we know we'll be able to draw a triangle and find the values that we need to do. Then we would just go to the half angle identity for sine, plug everything in, and go from there. If we wanted to rewrite cosine 5 pi over 12, same thing. Let's double this. That would be times 2, giving us cosine 10 pi over 12 all over 2. We can simplify this 10 pi over 12. That would be cosine 5 pi over 6 all over 2. And this 5 pi over 6 is going to give me a 30-degree reference angle, which is perfect. Now we can draw our triangle on our coordinate plane, substitute in the values into our half angle identity. And then it's the same process as we did in the first example.